Hello everyone, I'm the last presenter of this session, but before I begin, I would like to welcome everyone to stand up and stretch a little bit. It's a long session, and we all know it. Okay, why don't we just get started? Hi everyone, my name is Lei. I'm currently a postdoc at Princeton University, and this is the work that I did during my PhD at the University of Michigan, together with my co-authors, Jing Han, Jacob Getty, Steve Oney, and my advisors, Steve Oney and An Hong Guo. Let's talk about VRCopilot, authoring 3D layouts with generative AI models in VR. With the release of devices such as the Apple Vision Pro and the Meta Orion, AR and VR has been explored and applied in lots of areas, like entertainment, future of work, and social, architecture, the future of design and art. These experiences are becoming more and more popular, but then it comes with an increasing need for creating 3D scenes more efficiently. Now, recently, there's a new trend called immersive authoring that treats VR as both an application and a creation medium, and enables users to create VR in VR. For example, one of the leading game engines, Unreal, has this VR edit mode for users to use intuitive interactions such as direct manipulation to sort of create and add 3D objects in VR. And our research community also has keen interest in this paradigm. For example, prior work such as Spacetime has explored collaborative editing in VR, and our prior work, Flowmatic, explores immersive visual programming in VR, as well as our prior work, VRGit, that explores multiple users doing version control together in VR. However, a key limitation of all these prior 3D authoring tools is that they're all created through manual arrangement and placement of 3D objects. And we started to think about, can machine automate this process of creating and laying out 3D models for us? Now, Gen AI is a possible solution for creating content and has been successful in lots of 2D tasks, such as text generation and image generation. And if you don't know, there has also been active research on this topic called 3D scene synthesis. And essentially what they try to do is using approaches like diffusion models or transformers that can take a floor plan, such as room size as input, and to generate the layouts of objects as the output. Now, this is cool, but there are still a gap between these models and putting them to actual users in 3D design and authoring. For example, here is a generated results from one of the AI models. If you are an actual user, would you want to live in this room? To me, probably not, because the cabinet seems to be blocked. It seems there's very little room for me to actually comfortably walk around. So the first research objective of VRCopilot is to align AI with human preferences. Then when it comes to the question, is text prompting the best way to express our intent in VR? Do we still want to enter text prompts rather than all those already available interactions in VR, such as direct manipulation or natural languages? So to answer this question, our second objective is to design intuitive interactions with generative AI, especially in VR. Lastly, these generative models work kind of like magic. You have the empty room on the left, then boom, you have the layout on the right. The problem is that there's little user involvement in the creation process, just similar to how people do prompting nowadays and just hope for the best results that could come out. So it's really just AI created for you, not with you. And this relates to our previous talk, Who Did It? So our last objective of VRCopilot is to enhance user agency and creativity when working with Gen AI in VR. Now, without further ado, let me introduce VRCopilot. Our system is an immersive authoring tool where people can create furniture layouts in an empty apartment via just simple menu selection on their controller and directly manipulating and editing the 3D model. Now, if Gen AI can automate this process for us, we call this automatic creation. So via a button press or a voice command, the generative model can basically populate the full room layout for you. And then, of course, you can do small adjustments of the room, such as deleting the wardrobe or manipulating the nightstand to make it rotate and look nice. Now, a disclaimer here that our Gen AI model only generates the layouts of the 3D apartment, but not the models themselves. So we do not generate the furniture themselves, but instead we pull from our data set of thousands of models. So what Gen AI is really working here is just the layout, including what type of furniture to place and where to place them. Now, this is cool, but not quite satisfying because, again, it feels like AI created for you. So if we talk about human AI co-creation in VR, we're really thinking about this whole spectrum of machine automation. And automatic creation is really just at the very end of the spectrum where machine automated everything for you. So we also propose interactions that can gain users more control in this process. And that's called scaffolded creation. Now imagine using the same button press or voice command. Instead of giving me a room full of furniture, the system can show me a set of intermediate representation, or what we call wireframes. These are essentially what we will see later, blue boxes on the floor, and each with its own size and furniture category. That's what we call wireframe. This is similar to how people create floor plan via sketches in reality. And you can, of course, manipulate them freely in the room. And once you're ready, you can seamlessly switch from wireframe to actual 3D furniture layout and to view the actual result. You can also manipulate these furniture models, and if you want to design, let's say, a different version of your work, you can also turn back to wireframe like a draft. And what's interesting here is that besides just manipulating these wireframes, you can create your own wireframes. For example, deleting one, and then sketching directly on the floor, while speaking such as, I want this area as a sofa. And what the system will do is it will create a wireframe as well as the label sofa for you. After that, of course, this new version, what you can do is turn this wireframe draft back to an actual furniture layout. And with that, you get a furniture layout with updated layouts and the sofa that you just draw on the floor. This is called scaffolded creation. Now, to give user more granular control, we propose also manual creation that allows users to create and edit individual objects. For example, just notice how I point on the floor and then use my voice to say, create a chair here. And what the system will do is it will pull from our database again and give you 3 options to choose from. And you can use direct manipulation to select from one of these options that you like. And this interaction is inspired by the classic interaction called put that there, but in the context of VR creation. With the multi-model specification, users can gain more control, such as deleting multiple objects or regenerating one of the objects that you don't like, for example, the bed. And the full list of commands can be found in our paper. We have beyond these commands shown in the slides. You can imagine really building out the entire scene using manual creation as well. Now, that's the 3 ways of human AI co-creation in the spectrum of machine automation in VRCopilot. So we did 2 rounds of user studies. In the first study, we aimed to compare just generally the creation process with and without AI, because Gen AI plus immersive creation is so new to us. So we conducted a within-subject study with 14 participants where they created layouts both with and without Gen AI. And without AI, they basically just use menu selection and then direct manipulation, where with AI, they basically let the Gen AI take the lead and then populate the full room layout for them. And what's interesting is that we also pulled these creation results from participants and then conducted a workshop with a design expert with actual working experience in architect and interior design. And we evaluated the creation results from the participants. The expert basically did open coding of the patterns that they found in the top-down images that we've pulled from the creation results. And if they're interested in details, they can also view them in 3D in Unity. we have a lot of interesting findings. One of the key findings is that when creating with AI, we found that people tend to have more diverse functionalities and color palettes. So, for example, functionality relates to like what this room can actually do. If you look at the room that's created, let's say, with AI, it basically have more functionalities where you have, let's say, a sofa for seatings, a desk for working, and then storage, a cabinet for storage, versus for creation without AI, people tend to have less items, and that's for sure. And we also found that they have diverse color palette because like AI-generated results are usually having more random or like diverse color palettes, where in manual or like creation without AI, people tend to have a consistent sort of style or tone of color of this room. And we also found that creation without AI tends to have better consideration of spacing, such as circulation or daylighting. So users have pay more attention to, for example, if things are blocking the doorway or windows, and if they can comfortably walk around in this room. With these insights that we had about Gen AI in first study, we improved our study protocol and conducted a second study that basically compares these three ways of human-AI co-creation in VR. So during the task, the participants will basically create layouts using all modes, manual, scaffolded, and automatic. We gave them some constraints during the tasks, such as you need to finish at least 3 versions, and in each version you need to have, let's say, at least 4 objects, and also some objective goals, such as providing enough space for people to walk around. We measured users' perceived agency, creativity, and effort using surveys. So agency is basically their sense of being in control in the creation process, and creativity relates to their sense of being creative, and lastly, the effort, including physical and mental effort. We also conducted retrospective interviews with them. We did quantitative data analysis on all these metrics on the survey, and let me break it down for you. So basically, in agency, we found that manual creation have the most significant agency among users, and then scaffolded, and then automated. Basically, users will feel the most in control in manual because they have more control over the style of these objects themselves, besides just the sizing or the placement, versus in scaffolded, they have this additional control of the size and the type of object that they can define in the room. And the last one, automatic, would be the least in control one, because basically it looks like Gen AI already provides everything for them, and they don't want to move it that much. In terms of creativity, we found that in manual creation, this particular feature stimulates creativity the most, where people have multiple options in front of you. For example, one participant said, when I saw the bed, it's like bright green or yellow. I was like, maybe I can make this the theme of this room, and then make all these other objects follow the same theme. So you can choose between these 3 options, makes you feel more creative. Versus when you work with AI, it almost feels like it's already done for you, and then you will have the bias towards how it's placed and how it's designed, so you feel less creative. We didn't find any significant difference in perceived effort. We also have many other interesting findings. Because of time constraint, I won't elaborate too much. But basically, wireframes, the design of wireframes enable easy manipulation in VR, versus when manipulating 3D objects, it's hard for especially distant and things that are occluded. Also, people tend to have less understanding of Gen AI's capability. For example, they don't know that we can't really generate a red bed for them because the color label is not included in our data sets or the training at all. And lastly, we found that during the interview, people felt like using AI, it would be very efficient for them to create multiple rooms at once, and would be way more efficient than manual creation. Now, if we reflect a little bit on the findings, we think that offering multiple suggestions could be useful for creative inspiration. It could be applied to a lot of areas in like generative content creation tools. For example, GPT had this feature, like, which response do you prefer? And this is usually for the sake of improving their responses, but could be retargeted for like creative inspiration. But then it comes with the challenge of how do you make these suggestions more diverse instead of like giving very similar suggestions. In addition, there's also other potential ways of visualizing these multiple suggestions rather than just juxtaposition, like putting them side by side. Also, we found that scaffolding the creation process via intermediate representation is important and could give users more control and agency. In other contexts, for example, what if instead of giving me a 5,000 words essay, you could give me an intermediate outline of the essay? Or let's say in the task of 3D, can you give me an intermediate representation of the shapes? That's something that we haven't explored in this project. And there's some other like already explored approaches, such as using interactive diagrams for text or like image skeletons for image generation. So those are interesting ideas. Lastly, we think that exploring AI transparency in immersive environments is also an interesting idea. We have had some success in AI explainability and transparency in 2D text, such as using saliency map to indicate which feature the model is using. Now, extending it to the immersive space, can AI system explain their decision to the users via, let's say, immersive queries, where you can maybe just point to an object and say, why is this object here, and why is it black, something like that. All right, so that's about VRCopilot. Before I end, I just have a very quick announcement that I'm going to start as a professor at NJIT starting next year, and I'm kind of at this wonderful transition stage where I'm doing a postdoc at Princeton University. So I'm looking for like potential students and collaboration on the topic of AR, VR, and also AI-assisted authoring. Thank you so much.
We still have time for a question.
Thank you, great talk. I was wondering if you thought about creativity in VR tools, if encoding and setting behaviors. So this is like a lot more done in gaming, like a basic example would be a light turning on and off, or a door opening, but of course in gaming you want more interesting things, like you walk into a door and you get transported to a new place or something like that. Have you thought about using like encoding behaviors as a creativity tool and seeing if that maybe changes agency or creativity or control?
Yeah, of course. I think adding interactive behaviors to the 3D content out there is an interesting topic, and we have explored in one of our previous projects called Flowmatic, where we create this like immersive visual diagrams where you can do visual programming in VR that sort of specify the behaviors of objects, and that's definitely one interesting way to do that. And I think creativity is really a complex factor to sort of measure, and I think being able to sort of let them, like you said, define, let's say, when they enter the door, what would happen, and that sort of interactive behavior is just one way to sort of lead to more creativity. And also another term that we usually use, like expressiveness, like how much you can express with these tools. Yeah.
So thank you very much. Let's give one more round of applause for our speakers.